Alright, so in day 2 of our algebra review, what we're going to do is we're going to solve some more nonsense equations. We're going to do some inequality equations today. And again, this is more for a couple of reasons. Number one is representing solution sets, and number two is to write a signed number line. These are both very important concepts that we'll be doing later on in the class, especially in December when we're applying our derivative. So let's start out with this equation. 2x plus 3 is over x plus 1 is greater than 1. And if I go to solve this equation, what I need to do is I need to bring that 1 over to the left and subtract it. So I'm going to write it as 2x plus 3 over x plus 1 minus 1 is greater than 0. Now before I can compare it to 0, I have to subtract that 1. So I write that 1 as x plus 1 over x plus 1. So I'm going to write it as 2x plus 3 minus x plus 1 over x plus 1 is greater than 0. And then when I simplify it, I get x plus 2 over x plus 1 is greater than 0. So now I state that statement, and what I have to do is I have to decide when is that quotient going to be greater than 0. So if I look at that quotient, let me copy it down here again. So I have x plus 2 over x plus 1 is greater than 0. Now that's only going to be greater than 0 when I have a positive divided by a positive or a negative divided by a negative. So to help me determine that, I'm going to draw this little number line chart, and I'm going to put my signs in. So the numerator has a 0 at negative 2, so I'm going to put that in, negative 2. There's 0 there. I put my little x plus 2 over there. And then the denominator, x plus 1, has a 0 at negative 1. I put the 0 up there, and put x plus 1 there. And now if I put my test values in, like if I put my test values in the numerator and x plus 2, to the left of negative 2 they're going to be negative, and to the right it's going to be positive. From negative 1 to the left is going to be negative, and to the right it's going to be positive. Careful that it's a lot of times it falls this way where the negatives are on the left, positive on the right, but it doesn't have to be that way. And now what you're looking for is when is their quotient going to be greater than 0. The quotient is going to be greater than 0 when you have a negative divided by a negative or a positive divided by a positive. That's going to happen down here when x is less than negative 2 and above x is greater than negative 1. So then I have to write my solution set. So the solution set is also an important calculus concept. None of this is included. We would never include the denominator because you can't have division by 0. And in this particular case, I can't include 0 because it's not equal to. So it's from negative infinity over to negative 2, union with from negative 1 over to infinity. It's going to be very helpful for you to get good at these sign charts and then also writing the interval notation of the solution sets. That's something we do a lot later on in the course. Sometimes you might find yourself where you have like a couple of fractions that are greater than or less than. Let's do less than or equal to this time. Let's go 3 over x minus 1. Oopsie, x minus 1 is greater than or equal to 2 over 2x plus 3. Again, I can't compare these the way they are. I don't want to cross multiply. I would maybe lose solutions there. So I've got to move the 2 over 2x plus 3 over to the left. So I'm going to write it as 3 over x minus 1 minus 2 over 2x plus 3. It's greater than or equal to 0. The common denominator is going to be x minus 1 times 2x plus 3. The numerator I'm going to rewrite as 3 times 2x plus 3 minus 2 times x minus 1. It's greater than or equal to 0. When I simplify that, I end up with 4x plus 11 over x minus 1 times 2x plus 3. And that's greater than or equal to 0. Sorry. That's a greater than right there. Then I'm going to create my little number line chart. Let me see. Let's go to a new screen on that. So you have that 4x plus 11. So I'm going to have 4x plus 11. That's on the side. I have the denominator is x minus 1. And then 2x plus 3. And I'm going to create that little number line chart just like I did in the previous one. Okay. Careful about ordering these numbers now. That top equation, the 4x plus 11, that has a 0 at negative 11 fourths. That's a little bit less than, or a little bit less than negative 2, so there's a 0 there. The x minus 1 is the largest value. I'm going to put that 1 over here. So this one has a 0 there. And then the 2x plus 3 has a 0 at negative 3 halves. And I'll put a 0 there. For each one of these, they're going to be, when you put your test values in, these are going to be negative on the left and positive on the right. Again, don't fall into that trap. If I change the negative sign on the x, it would switch these. And now what I have to do is I have to figure out, like I have to use this number line chart to figure out the solutions. I want to know when this is going to be greater than or equal to 0, not less than or equal to 0. So greater than or equal to 0 is going to be a negative divided by a negative, or a positive divided by a positive. On the outside, below it's basically there are 4 different intervals. There's from negative infinity to negative 11 fourths, negative 11 fourths to negative 3 halves, negative 3 halves to 1, and 1 to infinity. From negative infinity to negative 11 fourths, I have a negative in the numerator, but the denominator is negative times a negative, which is positive. So negative divided by a positive is less than 0. We wouldn't include that. For the second interval, I have a positive divided by a positive, so that is positive. So negative 11 fourths to negative 3 halves is included in my solution. So negative 11 fourths to negative 3 halves. Now, just be warned, okay? In this one, it can be greater than or equal to 0. The negative 11 fourths would make the whole fraction 0. So that one is included. That's okay because that's in the numerator. But I'm not going to include the negative 3 halves. And the reason I don't include the negative 3 halves is because that would give me division by 0. We can never have division by 0 in this class. So that would not be part of the domain. That would be something we talk about in our next lesson. But don't include that negative 3 halves because that would give you division by 0. We're going to union that with, now the next interval is going to be a positive divided by a negative because it's the product of negative and positive. So that doesn't work. And then beyond 1, it's a positive divided by a positive. That does work. Again, we don't include 1 because that would be division by 0. So it's parentheses 1 to infinity. And in case I haven't said it before, we never include infinity or negative infinity. Okay? So again, today's lesson or today's problems, what you're going to do is you're going to solve a lot of nonsense inequality problems so that you set up these number line charts and then represent your solution sets. You're now ready to do assignment number 2.